Okay, so today we're going to talk about solving multiple step equations, special cases. Okay, so still in Unit 2, multi-step equations, special cases, slide 16, and I'm on note page 31 in my notebook. So I'm going to put that down in your TOC. Okay, so let's go ahead and turn to page 31. So at the top, we want to have special cases, solving equations. Okay, now when we talk about special cases, specifically, what we're referencing is there are three types of solutions that can occur when solving an equation. So, three types of solutions. Okay, one is a unique solution. One is no solution. And the last is infinite solutions. Okay. So if you have a unique solution, that means your answer has one possible fixed number. And for the most part, those are the equations that we've been solving. That we solve it and we can say x equals 7, x equals negative 2/3, where there is a specific rational number that when we substitute it into the equation will make a true math statement. The special cases come in when we talk about no solution. And the symbol for no solution is like a 0 with a line through it, where no number can create a true math statement. In other words, no matter what rational number that I substitute in to the equation for the variable, I can't make the statement true, right? Like 3 does not equal 7. If it did, I will lend you $3 and you can pay me back 7, right? And then the third type, infinite solution, is we use the infinite sign or the infinity sign for that. And it's any number will create a true statement. And when we solve these type of equations, these special cases, no solution and infinite, we're going to find that they have some similarities and that they have some differences in what we see when we're solving them and in what the original equations look like. So let's go ahead and solve an equation. And this is going to be our no solution equation. So the question is 2 minus 15n equals 5 times negative 3n plus 2. Now, one of the keys to identifying the no solution or infinite solution special cases is you want to go back to those rewind steps that we talked about. And one of the things we talked about with variables on both sides, for example, is that we always want to get all of the variables on one side of the equal sign before we deal with the fixed numbers. So I'm going to walk through my 5 steps as normal. So step 1, distribute. I have grouping symbols. So 2 minus 15n isn't going to change during the distribute phase, but I'm going to take 5 and multiply it by negative 3n, and I'm going to take 5 and multiply it by 2. So 2 minus 15n, 5 times negative 3n is negative 15n, and 5 times 2 is positive 10. Okay? So now I'm left with, I look and see, do I have combination? Over here, 2 minus 15n, one's a fixed term, one's a variable term, they will not combine. Negative 15n and positive 10, one's a variable term, one's a fixed term, they will not combine. Okay. So then I move to my rewind step, and this is the first thing in rewind, you want to get all of your variables on one side. So if I look, I should see negative 15n and negative 15n. They are the exact same variable term. So when I rewind them, by doing their inverse, I'm going to add 15n to both sides. We should see that they both cancel out because negative 15n and positive 15n, those are additive inverses that lead to 0. So I'm left with 2 equals 10. And does 2 equal 10? No, this is a falsity, right? This is false. This is not a true math statement. So because of that, I know that this is no solution. And any number that I tried to put in here to get a true solution would lead to a false math statement. So if I put 0 in, I'd wind up with 2, and I'd wind up with 10. Not going to work. If I put 1 in, if I put 7 in, if I put 304 in, I'm going to wind up with a false math statement. That's what it looks like to be a no solution. But one of the keys is that we eliminate those variables. Let's look at the identity. So we have 3 times 4x plus 2 equals 6 times 2x plus 1. So 3 times 4x, I'm doing the distribute step, plus 3 times 2 equals 6 times 2x plus 6 times 1. So 3 times 4x is 12x, 3 times 2 is 6, 6 times 2x is 12x, 6 times 1 is 6. Again, the variables are exactly the same. So that when I move to the rewind step, and remember, I always want to get all the variables together, so I should be rewinding one of the variables when I have variables on both sides. They eliminate, and I'm left with 6 equals 6. And this is a true statement. So that's going to be infinite or infinite. Some people call it all solutions. Because any number that I put inside will create a true statement. So if I put 0 in, this becomes 2. 3 times 2 is 6. This becomes 0. 6 times 1 is 6. If I put 2 in, I'd have 8 plus 2 is 10. 10 times 3 is 30. If I put 2 in over here, 4 plus 1 is 5. 5 times 6 is 30. I always get a true statement. Okay, so some of the things that are the same and some things that we should look for that are different. One of the things that is going to be the same is both sides of the equal sign have expressions. You know what? That's going to be way too wordy. How about an identical variable term is on both sides of the equation. Another thing that was like when using the rewind step, the variable terms eliminate out. Okay? Things that are different. One creates a false statement, while the other creates a true statement. Things that are the same. For infinite, the fixed term is identical on both sides after you simplify. Or we could say after CBLT step, combined step. Fixed number term is different on the sides of the equation after combined step. So what I mean here is that this is after we've done distribute and combine. If we look here, we can see that 2 and 10, these are the fixed terms. They are not the same, whereas negative 15 and negative 15 were the same. For the identity, both the variable term, 12x's, and the fixed term, 6, was the same before we did that rewind step. That's one way to distinguish what is an identity and what is a no solution. And that is our notes today for special cases. You have another assignment assigned to you in classroom to make sure you get that done as well.